Or is it?
It looks like find out.
Okay. You will need try distribution.
Chai? Chai.
I think it's try. Some people say chi.
Mitchell.
Let's see, I also use chi hair products, so I can see how it's chi. But also I have chai tea. So I guess I'm confused. Don't video this.
I thought chai tea was CHA.
Is it?
Hey, what's up, sexy beast?
IA? Or is it AI?
I think it's AI.
Alright.
That's what she just said.
For sigma squared is S squared. So this is population variance and this is sample variance. So if I'm given sample variance, I can assume that it's the population variance. Same thing for standard deviation. Okay, it's the same thing. Any questions so far?
No,
I don't know how I feel knowing I'm being video camera. I wish you wouldn't have done that. Okay, so. Okay. All right.
No cameras allowed.
So guys, here is the best part. Everybody looked at this distribution chart I've given to you for chai, whatever, chi.
Just say the C chart.
C chart, T chart, and Z chart. I like that, C chart. Okay, everybody look here. Notice.
How about you say chi?
See, you have spots that's like 0.995 and 0.005. Does everybody see that?
Yes.
So what we're doing tonight, and this is something y'all are going to absolutely love. Hi.
Wait, tonight?
Like, no, I mean like when you do your homework for this, okay? Hopefully y'all wrote that down, but I just erased. But if you did, that's fine. Alright, so, are you really recording? Okay, so, here's your curve, okay? If you notice, what C does is it takes both sides, okay? So you are going to do 1 minus the confidence divided by 2 tonight. Because there's 2 tails. Okay? So you will be looking for 2 numbers. You have a left-sided number, and you will have a right-sided number, in which we will learn how to find in just a second. We'll do that in a second. Degrees of freedom. You use degrees of freedom on this chart and your T chart. So on C chart and T chart, you use your degrees of freedom. It's just n minus 1, correct?
Yes.
Yeah.
So it's just 1 less. That's pretty easy. So if we're going to learn how to look at this, you are going to have a right value, R, and you are going to have a left value, L, that you pull off this chart. Okay? This is the only thing that's difficult about this.
Right tail and
You're going to have a right and a left. The right obviously goes with the right side, and the left obviously goes with the left side. What I want y'all to remember is your smallest value on top. Look at your top numbers. The smaller the value, the more left it is. The larger the value, the right it is. You read it left to right. If it's on the left side, it's left. If it's on the right side, it's right.
Okay.
Does that make sense?
Yes. Whoa.
Okay. That was positive. Okay, so if I'm trying to find the critical values, you're looking for 95% confidence, okay? And you're looking for the right and left, and your sample size is 18. So your degrees of freedom is 18 minus 1, which is 17. So you're looking at the 17 line. Hold on, I'm not there yet.
Yeah.
And then what you're going to do, 1 minus your confidence. So 1 minus 0.95 divided by 2 is what? Someone tell me what that number is.
0.95.
Miss, which one are we on?
It's on the bottom of that slide.
Page 2, but on bottom of the first slide.
0.025.
0.025. Yeah. So, okay. We're going to go to the left side first.
Hold on, can you?
Okay.
What is DX?
DF, degrees of freedom. It's exactly like yesterday on 6-2.
Hey.
Now, One more subtraction so we can find left. Left or right? Why did I put two L's?
The answer is yes.
Okay. So guys, we want to look at the left side, because notice there's bigger numbers there, so to see that? Okay? We want to look at the left side, so do 1 minus 0.025 in your calculator. 1 minus 0.025.
0.975.
0.975, that's what you're going to look at?
Yeah.
And go down to 17. And that number is 7.564.
Is there a little like Greek symbol for G or something?
I think it's that.
1 minus 17.
Oh, okay.
So,
Now, in order to find the right, you keep going over on 17 to 0.025.
Bless you.
So this one. So this one goes here, and 1 minus this goes here. Okay? And what do you get? Sorry.
30.1991.
30.191. And this is how you find your two values. Yes.
So just to backtrack to the, how you did the 1 minus 0.95.
Divided by 2.
Why,
Because there's two sides on this tail.
two sides and then one, why do you do 1 minus 0.95?
Okay.
1 minus point.
Okay, because right in here, if you look at this, this is considered 0.95 of your data. 0.95,
Yes.
95% of your data.
Yes.
So over here is 2.5% of it, and over here is 2.5% of it.
Yes.
But this is the upper 97.5%, and this is the lower 2.5%. So 0.025 is here, and 0.975 is here.
Okay.
Does that
And
make
are you always
sense?
gonna do 1 minus, however?
Always 1 minus, yeah.
And then divided by 2. Okay, got it.
What way? Being confused and Amish.
How do you stay confused and honest?
No, I said
I don't know, Ryan can answer that.
It was big meme. I was memeing in Wisconsin.
Are you drinking soda?
Hopefully your mom's looking at it.
No, now you gotta find the confidence intervals.
We're for the second slide.
Right when I hit record, he said that.
Okay, so when you find the confidence intervals for variance, you just take the square root of both numbers to find the standard deviation. So once you find variance, like always, you take the square root to find standard deviation.
Yeah.
So you have to find variance in order to find standard deviation. You have to find the variance first in order to find the standard deviation confidence intervals.
Variance.
Variance,
Standard deviation.
then standard deviation, out of alphabetical order.
What about standard?
Variance,
Goes variance.
then standard deviation. We always do variance first and then take the square root to get the standard deviation. We've always done that.
Yes.
We're going to do that again today.
Alright. I
Okay.
don't know the difference.
No, it's n times.
Okay. So here are the steps you do for this one. Like I said, you have to find variance first. This is your variance confidence interval. And then you find your standard deviation. Square root. Interval. So you find variance and then you find a standard deviation. You find variance and then you find a standard deviation. If you don't find variance, you're not going to get standard deviation correct.
And
Yes.
Eve.
All right.
Hold on.
Not too
Go
bad.
ahead.
Variance,
Is this table six?
CM,
Huh?
This table six?
This is, yes.